Hello everyone and welcome to today's video where we will be going through the general regulations of the operational procedures subject of the ATPL. We have prepared 5 of the most recent questions from various topics of the regulations of ops. I'll give you some examples, I'll show you some additional also information and documents, and I'll try to walk you through the answers here. So let's jump into question number 1 as we always do. So in accordance with ops regulations, if the flight is to be carried out of flight level 290, demonstration concerning oxygen equipment must be completed before. For the exams, there will be 2 cases that you need to remember. There will be the oxygen system check and the oxygen equipment demonstration. The oxygen demonstration needs to be always completed before takeoff, and this is what we essentially refer to as the briefing, which will be done by the cabin crew if this is an airliner. And the oxygen system test, this is done by the pilots in most cases, as well as the cabin crew when it comes to the some more modern airliners that do not use the chemical oxygen generators. This one needs to be done before taxiing. So for the exams, remember these 2 different scenarios. And also, if you are more interested about in the briefing process and what, how, and when needs to be done, you can find this in EASA's Easy Access Rules, especially in the part CAT, AMC CAT OP MPA 170, when it will give you all the information regarding passenger briefing. As you can see, I have pulled out the document, and you can see that before takeoff, the passenger briefing needs to consider all of these following items. This will be smoking, regulations, the stowed trays, and all the other information that is necessary by law and will also be asked during your exams. And of course, the use of the safety belts. And here you can see the passengers should also be briefed to extinguish all smoking materials when oxygen is being used, and where and how to use the oxygen equipment if required. So remember for the exams that you can find it exactly there, and before takeoff it needs to be demonstrated, and before taxi it needs to be checked. So now for question number 2. An aircraft has just been turned around and is ready to depart, but the RVR has dropped below 300 meters. The operator is approved to conduct low visibility takeoffs on the type. One of the pilots was unable to refresh his LVO qualification due to unserviceable equipment during his last OPC or operator proficiency check. The other pilot is LVO qualified. The airplane is a turbojet aircraft operated in commercial air transport. Which of the following is a correct solution to the situation? Now, here you need to just remember a couple things that I will tell you, especially for the exams. First of all, in order to conduct LVO operations, all crew members need to be approved and need to hold qualifications. This is also part of the LVO briefing that will be done before all LVO operations, and this will be provided in the briefing packs by the airline or the operator. Also, remember here that by definition, LVO operations, whether it is a takeoff or approach, start below 550 meters. So any operation, whether it's landing or takeoff, below 550 RVR, which is runway visual range, will be considered an LVO operation. However, you do not need special qualification and training to operate in these conditions. You only need special training to conduct these operations below RVR with 400 meters. So, although, for example, the pilot might not hold an LVO qualification, he still can fly LVO approaches, LVO takeoffs. However, not with the RVR not lower than 400, but it can be an LVO which is below 550. So there is the wiggle room. So of course, in this case, you need to delay the takeoff until the RVR is above 400 meters because the pilots cannot fly under LVO unless all the active crew is qualified to fly the approach. Above 400 meters, it is still the low visibility operation. However, it does not require additional certification. Also, this information can be found in the AOI of an airport because some airports might have their own different minimas because some airports might have worse equipment than stipulated in the regulations. And for example, they can only allow takeoffs with RVR of 500 or 450 meters. So it's always good to check these AOI packs. Question number 3. In the NAT HALA, what is the required setting for the altitude monitor alert system? So this will be your high altitude operations. This is similar to RVSM. However, RVSM now is used in these not HLA airspaces. So of course, this will be our flight, which reduces the separation between the aircraft. And here, the altitude monitoring and alerting system regulations will be the same for both. Now, this question is relatively it lacks feedback, so this is why I wanted to discuss it with you. There are a few things that you need to remember for your RVSM and reduced separation minima, generally speaking. So first of all, before takeoff, you need to check your altimeters, and they need to be within 75 feet of each other. However, before entering the reduced separation minima airspace, you need to make sure that your altimeters do not vary from each other by 275 feet. And this is your total vertical error. It cannot be more than 275 feet. However, you also need to report any altitude deviations over 300 feet in this particular case. So what is the required setting for the altitude monitoring and alerting system? It would be wise to select 300 feet because that is the correct answer. However, there is a lot of feedback that suggests that 275 feet is also correct for these questions. So if you come across this question during your exam, unfortunately, if 275 is available, it will be most likely the correct answer. Although 275 is the total vertical error that is can be shown on your altimeters, and the 300 feet is the maximum altitude deviation that you can make. Otherwise, you need to make a report, which needs to be received within 72 hours by the appropriate authority. And now for question number 4. So during boarding, a visually impaired passenger notifies the crew that his or her accompanying passenger or a buddy has been assigned a seat away from him or her. And after all passengers have taken their seats, the only available side-by-side seats are the emergency exits. The PRM, so the passenger with a reduced mobility, and the accompanying passenger, also called the buddy, may not be assigned these seats as direct access to the emergency exit could be impeded. So there is a list of different cases in the same document that I showed you previously, which essentially states where and how which passengers with reduced mobility can sit. Generally speaking, if there is a chance you can impede the access to emergency exit, so you need a service dog, or you have, for example, a broken leg, or as in this case, you're visually impaired, this limits your seating options, and emergency seats are not in an option anymore. Also remember for the OPS exam that there are 3 types of PRMs, or passengers with reduced mobility, and they will be coded with specific letters. These letters are Romeo, Sierra, and Charlie. An easy way of remembering it is that Romeo needs help on the ramp, Sierra needs help on the stairs, and then Charlie also needs help in the cabin. So ramp, stairs, and Charlie. Romeo, which is the least severe, Sierra, which is a bit more severe type of reduced mobility, and then Charlie are passengers that need the most help. And now for the last question. An approach when either part or all of an instrument approach procedure is not completed and the approach is executed with visual reference to the terrain is the definition for a visual approach, and this will be the correct answer. Remember that a visual approach is actually an IFR procedure. This is when we are flying IFR and we are telling the controller that, hey, I can see the runway perfectly well, I can safely navigate towards the runway. In that case, you can request a visual approach, which may or may not be approved by the controller, and only then, once approved, you can visually, so without use of any instrument landing systems, or you can actually land the aircraft without the need of flight directors. However, there is another answer that I see a lot of people mistake this question with, and that will be circling. And I wanted to just show you really quickly, this is an excerpt from one of the presentations we did before from Airlo, how a circle to land approach differs from a visual approach. A circle to land approach will be used in cases when there, for example, is an instrument approach to one runway, but not the other, but the winds do not permit you to land on that runway. This is the most common situation. So, for example, you're trying to land, as you can see on the right side here on the presentation, on runway 09. However, there is a very strong tailwind on that runway. If runway 27 does not have an ILS, for example, you can approach it on 09, and then at the certain minima, you can brake to the right, enter the circuit, and land. This is a circle to land approach. By definition, These approaches will be offset by more than 30 degrees from the runway center line. So if there is an offset of more than 30 degrees, generally speaking, this will be considered circle to land. So also if you're approaching 09er from a very hard offset, it also could be considered circle to land. And this is an example of a circle to land approach. So as you can see here on the right side, you have circle to land minima, so MDH, minimum descent altitude, which is consistent with non-precision approaches, is 175 meters. So here you can see, here on the left side, you're approaching perpendicularly, 90 degrees angle to the runway on the radial 358, and then an MDH. If you have the runway in sight, you can brake to the left and then safely navigate visually to the runway. However, as you can see, this is still an IFR procedure. You still need to use your instrument. It is not flown fully manually. It is only flown visually after reaching the MDA and having the runway in sight. Thank you so much for joining. This will be everything for today's ops video. I hope to see you in the next one, and I wish you all the success and luck in your future exams. Thank you for watching, and bye-bye.